Welcome to iLecture Online. Quite often, taking numbers and putting them into a graphical format helps us understand what the numbers mean and helps us quite often to predict what may happen in the future or what the next value may be. So in this case, we were given certain times when the sun would rise on various days of the year. On January 1st, the sun will rise at 7:14, on February 1st on 7:08, March 1st at 6:45, and so forth. Then eventually the question is, when do we think the sun will rise on September the 1st? The number isn't given. We want to try to predict, to guess, or make it a best guess based upon what the graph looks like. So we already have pre-prepared here a graph. We have the months of the year, and of course that would be April 1st, May 1st, June, July, August, September 1st, and we have 5 o'clock, 6 o'clock, 7 o'clock, 8 o'clock in the morning. So let's go ahead and plot those points for the dates and the times that we know. On January 1st, the sun rises at 7:14. That would be just below the 7:15 point. That would be right about there. On February 1st, it's at 7:08. So that would be just slightly over the halfway point right there. On March the 1st, it's 6:45. So that would be 6:45 would be right here. On April the 1st, it would be 6:09, so this is 6:15, that's 6:09 would be right about there. On May 1st, it's 5:37, so this is 5:30, this is 5:45, 37 would be just about there. On June the 1st, it's 5:20, so this would be 5:15, 5:20 would be right about there. And July 1st is 5:13, so that's 5:15, 5:13 would be right below there. And on August the 1st, it would be 5:32, so it would be right about there. All right, now we also know that the sun will rise the earliest on June 21st, even though that's not indicated there. So we know that this probably drops down to somewhere around this area on June the 21st. First day of summer, at the summer solstice. So now based upon those numbers, what does that graph look like at those data points right here? So we can see that we can predict this to be there. And if we want to then draw the graph, notice that it first comes down like this, gets pretty steep, then it becomes a little less steep, it drops down here, then we expect it to drop down a little bit like this and then start coming back up. So that would be kind of like this. And then we would see that continue to increase at a steeper and steeper and steeper rate. So we know that this would hit the curve right about that time, approximately. And so we can say then that on September 1st, we would expect for the sun to rise probably somewhere between 6 and 6:15 a.m. based upon the shape of the curve. I know that this is kind of an interesting curve right here. We know that should go lower and then back up, something like that. And then the curve comes back up, becomes steeper. So we would expect it to become steeper before it starts leveling off again based upon what this curve looks like. So based upon that prediction, we know that it'll probably somewhere in that neighborhood, somewhere between 6 and 6:15 in the morning for September the 1st. Again, notice when you look at the numbers right here, it doesn't say very much, but then if we take those very same numbers and we plot them on a graph, we get a much better feel for what the numbers represent. And you can see then graphically how the time that the sun rises in the morning changes throughout the year. So it's not a straight curve, it's kind of like an S curve, and an S curve come back up, so kind of in that general shape. And again, the lesson here is to realize that if we just look at numbers by themselves, they don't necessarily tell us very much, but if we put them on a graph where we relate one variable to another, then we get a much better feel of what that might look like, and that's how it's done.